Hello everyone, welcome back to another info index video. Today I will be talking about the concept of completing the square. Now what is completing the square? Completing the square involves taking the quadratic in standard form and expressing it in vertex form. The goal is to express ax squared plus bx plus c into the form a bracket x minus h squared plus k. The purpose of completing the square is that it lets you easily find the vertex of the quadratic function. The vertex is the point where the value of the output is maximized or minimized. When you have a quadratic in vertex form, the vertex is located at the point h, k, where h is the x value that will give the maximum or minimum value k. In both standard and vertex form, if a is positive, the quadratic will have a minimum value, and if a is negative, it will have a maximum value. Now here is the procedure for completing the square. Say we have a quadratic 3x squared minus 12x plus 16, and we wish to express it in vertex form. First, we need to factor out the coefficient on the x squared term for the x squared and x term. So what this means is we should factor the 3 from the terms 3x squared and negative 12x. Doing that gives us 3 bracket x squared minus 4x plus 16. Next, take the new coefficient on the x term, divide this value by 2 and then square it. Add and subtract this value inside the brackets. The new coefficient on the x term is negative 4. Dividing that by 2 and squaring it gives us 4. So we should add and subtract 4 inside the brackets. Doing that gives us 3 bracket x squared minus 4x plus 4 minus 4 close bracket plus 16. Move the subtracted value outside of the brackets by multiplying it by the coefficient on the brackets. We need to move negative 4 outside of the brackets, but we need to multiply by 3 due to distributive property. Doing that gives us 3 bracket x squared minus 4x plus 4 close bracket plus 16 minus 12. Now we have 3 bracket x squared minus 4x plus 4 close bracket plus 4. If you haven't noticed, the polynomial inside the brackets is a perfect square trinomial, and as such we can factor it. X squared minus 4x plus 4 is equal to x minus 2 squared. Substituting this value back in, we get 3 bracket x minus 2 squared plus 4. We can always check that this is equal to the original quadratic 3x squared minus 12x plus 16 by expanding it. Now here is a practice problem. Express 2x squared minus 16x plus 35 in vertex form. Feel free to pause the video to try it on your own. Here is the solution. First, factor out 2 from the terms 2x squared and negative 16x. This becomes 2 bracket x squared minus 8x plus 35. Next, take the coefficient on x. This is negative 8. Dividing that by 2 and then squaring it gives us 16. Add and subtract this value inside the brackets. Doing that gives 2 bracket x squared minus 8x plus 16 minus 16 close bracket plus 35. Move the negative 16 outside of the brackets, but we have to multiply it by 2 because of distributive property. Doing this gives us 2 bracket x squared minus 8x plus 16 minus 32 plus 35. Simplifying this gives 2 bracket x squared minus 8x plus 16 plus 3. Finally, factor the perfect square trinomial that is inside the brackets. Doing that gives 2 bracket x minus 4 squared plus 3. And we are done. Here is another practice problem. Find the minimum value of x squared plus 6x plus 14, and find the x value that produces this minimum value. As always, feel free to pause the video to try this on your own. In order to solve this, we should first express the quadratic into vertex form. First, factor out 1 from the terms x squared and 6x. Doing this gives x squared plus 6x plus 14. Taking the coefficient on x, which is 6, dividing it by 2 and then squaring it gives us 9. Add and subtract 9 inside the brackets. Doing that gives x squared plus 6x plus 9 minus 9 plus 14. Next, simply move negative 9 outside of the brackets. Doing that gives x squared plus 6x plus 9 minus 9 plus 14. Finally, factor the perfect square trinomial inside the brackets and simplify. Doing that gives x plus 3 squared plus 5. Recall that for a quadratic in the vertex form a bracket x minus h squared plus k, the vertex is located at h, k. In this case, a equals 1, h equals negative 3, and k equals 5. Therefore, the vertex is located at negative 3, 5. Therefore, the minimum value is 5, and the x value that produces it is negative 3. We know that this is a minimum value since the value of a is positive. To summarize, completing the square allows you to convert a quadratic from standard form into vertex form. The vertex form of a quadratic is a bracket x minus h squared plus k, and the vertex is located at the point h comma k. If a is greater than 0, then k represents the minimum value. If a is less than 0, then k represents the maximum value. H is the x value that will give the value of k as its output. To find the maximum or minimum value of a quadratic in standard form, you can complete the square and express it in vertex form. This concludes the Info Index lesson on completing the square. If you enjoyed, make sure to leave a like and subscribe for more content.